water is draining out of a cone-shaped tank at 2.5 cubic meters per minute. They tell us how big the tank is. At what rate is the water level dropping when the depth is 2.8 meters? So inside this cone-shaped container, there will always be a cone of water shaped like the tank, only probably smaller. And we're measuring the size of that water cone. And they're talking about the volume of that cone because they're giving cubic meters here. So the volume for a cone, you may know, is 1/3 pi r squared h. Now, that has two variables in it, and we've seen that with implicit differentiation we can handle things with two variables, but it's even better if we can condense this down to one variable, and there is a way to do that here. Because in a cone, we have this relationship that the height of the cone to its radius is always the same ratio. If you drew a triangle inside this that was, say, half the size of the full cone, that would be 4 by 1.5, half of the total height, half of the total radius. And no matter where you do those triangles, no matter how far up you go in the cone, those triangles are always similar, which means the ratio of radius to height is always going to be the same. And the radius to the height will always have the ratio 2.5 to 8. That's by the argument is that all these triangles are similar, or that the angle at the point is the same no matter what size the triangle is. Therefore, this ratio is always the same. And if we solve that, we get the radius is, what's 2.5 divided by 8? 0.3125 times h. Or I suppose I could have written 5/16. Make a fraction, double both sides of this to get a fraction. You could also say the radius is 5/16 of h. I might stay with that. It's a little bit easier to write. Okay, the point of having this is that if we plug it into our volume formula, it goes from having two variables to only having one, and that's an improvement. So volume equals 1/3 pi. The radius is 5/16 h. And it's squared, and then we have that last h. So this is 1/3 pi r squared h. If we clean that up, we get that the volume is 5 squared is 25, and we have our pi, and we have h cubed, and in the denominator we have 16 squared is 256 times 3 is 768. Not the greatest fraction I've ever seen, but there it is. So that's the volume in terms of the height, and now we have something we can differentiate. The derivative of v is just dv, that's no problem. And on the right side, the power rule tells us we do 3